This is Algebra Lesson 4-1, using graphs to relate two quantities. Now you can use a graph to visually represent the relationship between two variable quantities as they both change. Graphs are very handy for this because you can look and see how one variable is affecting the other variable. For instance, as the number of magazine subscriptions you sell goes up, the amount of dollars that you earn also will go up. All right. The graph below shows the amount of gasoline in Jamie's car after she fills up her tank. What are the variables? Describe how they are related at various points on the graph. Okay, so our two variables are obviously, down here we have time, and it is measured in days, and we have gas, which is measured in gallons. So those are our two variables. The variables are time, which is measured in days, and gas, measured in gallons. Okay. Now, obviously, the gas is dependent upon the time. The more you drive your car, the more days you drive, the less gas you will have. Okay, which basically is how we could describe how these two variables are related. We could say that the amount of gas decreases each time Jamie drives somewhere. So the amount of gas decreases each time Jamie drives somewhere. Okay. And it stays constant. Amount of gas will stay constant. For instance, there's a constant right there, and here is where it's staying constant, which means she's obviously not driving there. But here she's driving, and obviously if she's driving faster or she steps on the gas really hard, like right there, she's going to use more gas. Maybe she's merging on the freeway right there. So she had to stomp on the gas to merge on the freeway to get to constant speed. So therefore, she goes down faster. And then here, it just gradually is decreasing over time. Okay. So those are how those variables are related at different various points on the graph. Okay, so if it's constant, that means she's not driving. Here, she must be going fast. Okay, because the faster you go, the more gas you use. That's just a typical thing to know about when you're driving a car. The slower you go, the less gas you use. All right. Tables and graphs can show both relationships between variables. Data from the tables is often displayed using a graph to visually represent the relationship. Okay. Here we have a table in this particular problem right here. It says we have a table here which has the number of days and then has total customers. The table shows the total number of customers at a car wash after 1, 2, 3, and 4 days of its grand opening. Okay. Which graph could represent the data shown in the table? So on the first day, they had 61 customers. On the second day, they had 125 customers. Third day, 177 customers. And fourth day, 242 customers. Okay, so obviously, as the days increase, so do the number of customers. So as days go up, number of customers goes up. Okay, and you can look at this, and if you look at this graph, we definitely know it's not C, because as you can see, as the days increase going this way, the customers is decreasing. So we know it's not C. Same thing with D. We know it's not D. So it's either A or B. Now, if you look at it, there's a huge jump between 177 and 242. Here, there's just barely a little bit of an itty bit of an increase. Here, we're like day 1, 61, day 2, 125. That was a big jump. 125 to 177, modest jump. 177 to 242, bigger jump. So the answer here would be A. If you look at your graphs and you look at how the days and the customers are related, you can clearly see that it happens to be the graph letter A. Now, in the above example, the number of customers, which is on the vertical axis, that's your up and down axis, depends upon the day, which is on the horizontal axis. When one quantity depends upon another quantity, you show the dependent quantity on the vertical axis. Obviously here, the number of customers is completely dependent upon the number of days. Okay? The longer the car wash is open, the more customers know about it and the more customers frequent it. So here we can clearly say that the customers depends upon the day of the number of days. Okay. When Malcolm jogs on the treadmill, he gradually increases his speed until he reaches a certain level. Then he jogs at this level for several minutes. Then he slows to a stop and stretches. After this, he increases to a speed that is slightly slower than before and jogs at this speed for a while before slowing to a stop again. What is a possible sketch of the graph that shows Malcolm's jogging speed during his workout? And we have to label each section. Okay, so the first thing we have to do is we have to figure out the independent and dependent variable. Independent always goes on the x, dependent always goes on the y. Okay, and in this particular case, as we're looking at it, he gradually increases his speed. So time is one variable and speed is the other variable. Time is never dependent on anything. Okay? Time is an independent variable because it just is. So we'll put time here down on the x-axis. Okay? And this happens to be time in minutes. And then we'll put speed here on the y-axis. And this would be in miles per hour. All right, so we've got our two axes labeled. Now we need to look at it. It says when he jogs on the treadmill, he gradually increases in speed until he reaches a certain level. So a gradual increase of his speed would be probably something like this. He's gradually increasing his speed. He reaches a certain level. Okay, maybe he's even going faster. There we go. And he says until he reaches a certain level. Then he jogs at this level for several minutes, which means he's going to be flat for a little while. Okay. Then he slows to a stop and stretches. Okay, slows to a stop, stretches. Okay. Then he starts again and jogs for slightly slower than last time. And then he goes down again. Okay, so obviously I need to get my y-axis a little bit bigger here, so I'm going to do that really quickly. I want a really big thick line there, so I'm going to go with my line down here. Oops, I wanted it in black. I should have changed it into black. Let's do this. I need this. I need my line like this. I want it really thick, and I want it in black. So then I can do... That's a little too thick, isn't it? That's not the same as it was before, so let's do this. Let's change this to not quite that thick. There we go. That looks a little bit more like my other line. There we go. I can get rid of this. Okay, so there we see that there. I don't need this little dot here because whoops, I did not want that. I don't need, whoops, do not need this dot right here, so I'm going to get rid of it. There we go. Now I need to label my sections of my graph. Okay, so I will say increases, whoops, there I go again, drawing with the same thing here. I need my pen back. Okay, so he's increasing right here. Okay, and here would be a constant speed. Here is the decreasing speed. Right here is where he's stretching. He's increasing again here. Okay. Constant speed again here. here we're decreasing again. So we've labeled all of our sections. The last thing we need to do is we need to title our graph. Okay, every single time you have a graph, you should title it. Okay, I'm thinking since he's working out and his name is Malcolm, let's call this Malcolm's workout. Now, each graph that someone does is going to be slightly different than the others, but that's a pretty decent, as long as you label the sections and it makes sense, then it's going to be very logical on how you make your graphs. So making a graph from data is not all that complicated, as we can clearly see here, and it does help to basically tells a story with a picture versus a whole bunch of sentences. All right, your closure question for today. What does a non-vertical, non-horizontal straight line on a graph imply about the two variables? A non-vertical, non-horizontal straight line. That means it looks a line that looks like this or a line that looks like that. Okay, what does that imply? Because it's non-vertical and non-horizontal. What does that imply? Make sure you write that into your notes, and that is the end of this particular video.